So let us take an example now. So the first simple example that I'm going to start with is double integration 0 to 1, 0 to y, xy dx dy. So try to understand this first example. If you are through with this first example, the rest of them will be simple. So based on whatever explanation we have taken in the earlier part, here the inner limits are 0 and y. Clearly you can see that the inner limits are in terms of y. So obviously किसके variables है? X is equal to x is equal to opposite to y as we have taken. So opposite variable, so we will integrate with respect to x first. And obviously since the inner variable is x is equal to 0 and x is equal to y, the limits, outer limits will be y is equal to 0 and y is equal to 1. So my integration I, this is an important step to understand. I will repeat again for those who have not understood, pay attention. The inner limits are 0 to y. If the variables are in terms of y, that means obviously we take the opposite variable. So inner limits will be x is equal to, and we integrate with respect to x first. This is what we have seen in the explanation. And then since x is taken up, obviously the outer limits will be for y and we integrate with y later on. So you can solve it directly also, but since it is the first sum, I'll do two integrations. First I'll write it as I1 and then we'll solve I1 and substitute back in the integration I. So we can consider, let I1 is equal to 0 to y xy dx. So my double integration sum now is converted into single integration. So this is easy for you. Make a note of this. If the integration is with respect to x, my y is a constant. So anyway, this y becomes a constant term. Okay, and that can be taken outside the integration. So y is taken outside the integration. I'm just left with this. So if I integrate this now, it's a simple integration. The integration of x with respect to x is x square by 2. The limits of integration is 0 to y. Now let us substitute the limit. The rule is upper limit minus the lower limit. So that will become, first you substitute y square, then 0 and upon 2. So my first integration answer, I1 answer, is y cube by 2. So first integration I've got. Now this I1 I will substitute back in this equation. So I have solved this first integration. Now I will substitute back that in this and I will solve the next single integration. So substituting I1 in equation number 1, I will get integration, that is 0 to 1. This is y cube by 2 and dy. It's a very simple integration. Y cube, the integration is y square upon 4. And this 1 by 2 is outside the integration anyway. So the limits of integration here are 0 to 1. Okay. So that will be 1 by 8. Which is my final answer for integration. So as simple as that, you can convert it into two single integrations and then solve, or you can directly do it whatever it is. So whatever you find easy, since this was just the starting, first 2-3 sums I'll do it by solving single integrations only. Let us take similar example on this. Now the limits of integration are this. So you have to solve this integration. The solution for this now, pay attention again. Inner limits, you just have to check the inner limits. So just go and check the inner limits. The inner limits are what? The inner limits are for in terms of x. So if the inner limits are in terms of x, that means the limits are for y, of opposite variable. So if the inner limits are in terms of x, we will integrate with respect to y first. This is what we have seen. Since the inner limits are in terms of x, we integrate with the opposite variable. We will integrate with respect to y first, and then obviously we'll integrate with x later. So my integration I again will become y is equal to x square, y is equal to 2 minus x. First I will integrate with respect to y and then with respect to x. So these limits are for x. So the outer limits are for x. I name this as equation 1 as we did in the earlier sum. So again I may assume as I1, solve this bracket which is there in the integration, solve that I1, get the answer for I1, substitute back in your equation 1 and again solve that single integration and get the answer for final I. So we'll do the same procedure. So let us assume that first integration I1 is the integration which is given in the brackets, right? Okay. So now I have to integrate with respect to y. So y integration with respect to y is y square by 2. And the limits are x square 2 minus x. Right? So now you use the rule upper limit minus the lower limit. Okay, so you can keep this as it is or you can open the brackets, whatever you feel. So let me simplify this. So let me open the brackets, use a minus b the whole square. It is a square minus 2ab plus b square. Okay, then later on what you do is you write x raised to square square, that is here it will be a square x raised to 4. Okay, so this is what you will get after. This is the answer for I1. Now you will substitute this answer of I1 in your first equation as we did for the earlier sum. Let us substitute that answer of I1 in the first equation. So the answer for I that you will get is, the outer limits are 0 to 1 and this whole integration answer as it is. Let us substitute this whole integration answer as it is. So you will get dx. Now a simple integration, that is you have to integrate with respect to x. So constant 1 by 2 will come outside. Let us integrate with respect to x. The integration of constant is 4x. Then this 4 will be as it is. Integration of x with respect to x will become x square by 2. X square integration is x cube by 3. And x raised to 4 integration is x raised to 5 upon 5. The limits of integration are 0 to 1. So now we will substitute the upper limit and then the lower limit. So let us substitute the upper limit first. So that will be plus 1 by 3 minus 1 by 5. This is your upper limit. And anyway, if you substitute the lower limit, that will become 0 because everywhere 0 multiplied by any number is 0 as we know. So we will get this. So let us simplify this. After simplifying, you will get the answer as 16 by 15. So my final answer for integration is 16 by 15. So I hope the concept is clear now. There is no confusion. Usually what you do, look into the inner limits and then you decide with what you should integrate first. One more example we can take. Now I will not solve by I1, I2. That was just for your understanding, or that was first two sums. I will do it directly. So you will get the idea of both the things. Let us take the next sum. the sum is 0 to 1 and integration 0 to under root of 1 minus x square xy dx dy. Now again, as we know, what did we do? We looked at the inner limits. The inner limits now clearly are in terms of x. Since the inner limits are in terms of x, we will integrate with respect to y first. So obviously this will become, we will integrate with respect to y first and then later on with x. Okay, so usually we look at the inner limits and we decide with what shall we integrate first. So whatever the limits are there, that variable, if you have in terms of x, we integrate with the opposite variable, that is with respect to y. Similarly, if limits are in terms of y, we will integrate with respect to x first. So let me integrate this. I am doing it directly, so whichever method you feel easy, you do that method. Now integration is with respect to y, so my x will become a constant term that will go outside the integration, and you will have under root of 1 minus x square. Here you'll just have y dy. Okay, this way. So now integration of y with respect to y is y square by 2. So that will become 0 to 1. So that will become y square by 2. The limits are 0 under root of 1 minus x square dx. Okay, so 0 to 1. Then you have 1 minus x square by 2 dx. I substituted the limits. Under root of 1 minus x square, the whole square becomes 1 minus x square, and then the lower limit, which is 0. So this is what you will get after solving. So let me simplify this. Let me multiply this x inside. So we will get 0 to 1 x minus x cube by 2 dx. So again, it's a simple integration. 1 by 2 is a constant, can be taken outside the integration. We'll take the integration for x, that is x square by 2, and integration for x cube, that is x raised to 4 upon 4. The limits are 0 to 1. So now if I substitute the limits, what will I get? 1 by 2 minus 1 by 4. So if I simplify this, my final answer for integration is 1 by 8. Okay, so it's not compulsory always that you need to denote it as I1 and then solve I1 and substitute back in your equation 1, which we have done for sums 1 and 2. So totally depends on your choice whether you do it directly or you do by single integration 2 times. Okay. Let us solve a similar sum. One more sum we'll take. Now a small change is there. Here both integrations are limits are constants. Here I have not given any in terms of x or y. Now clearly we can see that this is a case 3 problem. When I explained both the constant limits are given and dx dy is given, this becomes your case 3 problems. Now the order of integration is not important at all. So you have to decide whether to integrate with respect to x first or y first. Okay, so here it is your decision. So for me, I feel let me integrate with respect to x first. You can do it by y also, that won't be a matter. So let me integrate with respect to x first. And then later on with y. So this is what you can do. Now after you can do it directly or do by I1, I2. Let me do it directly only. Let me solve the inner integration. In the inner integration, we can see that 1 plus y square is constant because we are integrating with respect to x. That 1 upon 1 plus y square can be taken outside the integration. So inside I am left with what? 0 to 1 dx upon 1 plus x square. So now let me solve this. What is the integration of this? Yeah, correct. Very good. The integration for this is tan inverse x. So this will become 0 to 1, 1 plus y square dy, and this is tan inverse x 0 to 1. So let us substitute the limits. You know it very well. Tan inverse of 1 is pi by 4. If you don't know, let me write here. Okay, and tan inverse of 0 is 0. That is clear. So this will become 1 plus y square dy, and the answer for this is pi by 4. Now pi by 4 is a constant term that can be taken outside the integration. Okay, this is not 11, this is 1. Okay, so that can be taken outside the integration. So you will have pi by 4, 0 to 1, 1 plus y square dy. Again the same integration by same it is integration with respect to y. The answer is tan inverse of y, and the limits of integration are 0 to 1. So again, if I substitute the limits, that will be tan inverse 1 minus tan inverse 0. Tan inverse 1 is pi by 4. So again the answer for this will be pi by 4. So final answer will be pi square by 16. Okay. So this is your final answer, pi square by 16.